This is the second video on finding the rational zeros of a polynomial using the rational zeros theorem, okay? So remember, we want to find our p-value here, which is going to be the constant. We want to find our q-value, which is the leading coefficient, okay? We're going to factor both of those completely, all right? And we're going to use the ratio of p over q to find the possible rational zeros, okay? Then we're going to use division, synthetic division, to test and see if that's actually a zero using the remainder and factor theorems from the previous section, okay? And we're going to keep doing that process until we find all the factors, okay, of this polynomial function, okay? So first thing, p is the constant, so p is going to be 6, all right? Now all the factors of 6, well, we know 1 times 6, we know 2 times 3, okay? And we need the plus and minus versions of all those. So the possible factors of p are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, okay? Q is the leading coefficient, 2. Okay, we need all the factors of 2, which is just going to be plus or minus 1 and plus or minus 2, okay? So now we need to find all the possible ratios here, P over Q. So we'd have 1 over 1, we'd have 2 over 1, we'd have 3 over 1, we'd have 6 over 1, all plus or minus. Okay, then we'd have 1 over 2, 2 over 2, 3 over 2, and 6 over 2, okay? And any repetition there, we would only list those once, of course. So let's look at all the possible zeros. There's a lot of those here, okay? So plus or minus 1, that's 1 over 1, but it's also 2 over 2 would simplify to that. So notice I only list that once, okay? 2 over 1 is here. 1 over 2, obviously, is here. 3 over 1 occurs twice. It's 3 over 1, but it's also 6 over 2. Notice we only list the plus or minus 3 the one time. We got another fraction, plus or minus 3 halves. And then finally, I've got plus or minus 6 over 1, okay? So now we want to divide. We want to test. We're going to have to test some of these. There's, the odds are here that the first one I test, maybe it works, maybe it doesn't, okay? But we're going to continue the process until we find one of the zeros, and then hopefully we can factor whatever's left over, okay? So we're going to test positive 1 first and see if that works. So we're going to kind of sprint through the synthetic division here, okay, and see what our remainder is, okay? And the remainder, when we use positive 1, is negative 4, okay? So because that remainder is not 0, we know x minus 1 is not a factor, okay? So positive 1 didn't work. Now we want to try negative 1 and see if that works, okay? So we're going to try negative 1. We're going to sprint through that. Okay, hopefully the remainder is 0. That means we have one of our factors, but it's not, okay? So the remainder here is not 0. So that tells us that x plus 1 is not a factor, okay? So I need to test something else, all right? I'm going to stay away from fractions for now. Some of you guys might struggle with fractions, but I think it's easier just to test the whole numbers. And eventually we'll get to a factor. So let's test number 2 here, positive 2. All right, let's go through the synthetic division. Again, you know this process by now. And okay, we get a 0 there for the remainder, okay? So what that tells us then is that x minus 2 is a factor, okay? So we've got one of our factors, x minus 2. And we're going to use these values here to create our quadratic, okay? Because we're dividing a cubic by a linear. So we've got x minus 2, and then it's 2x squared plus 5x minus 3, okay? So our next question is, can that be factored, okay? If it can't be factored, we can use the quadratic formula, but this can be factored. You could also continue to use trial and error and just keep going through the possible zeros here until you find the remaining factors, okay? But hopefully you recognize you can factor that, and it factors as 2x minus 1 times x plus 3, okay? So this is the 3 factors. These are the 3 factors of this polynomial function, 2x cubed plus x squared minus 13x plus 6, okay? So the zeros then are going to be positive 2, positive 1/2 comes from here, and negative 3 comes from here, okay? Notice all of those are multiplicity 1. I'm not going to print that out here. You can understand all these factors occur one time, so each of these zeros has a multiplicity of 1. Now notice 2, positive 1/2, and negative 3. were all part of our possible rational zeros up here, okay? So I feel really good about these being the zeros and these being the factors of this polynomial function, okay? So that's how you use the rational zeros theorem to find all the zeros of polynomial functions.